Good afternoon. I'm sorry we're starting a little bit late. I had a computer issue and was having trouble logging on, and my battery's okay. Anyway, apologize about that. I am going to do some basic math today. I'm looking towards January, and there's some work problems I want to do that require what are called system of equations and algebraic equations. And I've been meaning to just cover our basic algebraic equations. So I've been trying to rotate through the lesson packets, and we haven't done a basic math. Again, I keep trying to talk about positive and negative integers and numbers, and those kind of come up as we do these. But what I thought I would do is I went through the basic math to try and look at things that normally students have issues with, and normally percents are kind of difficult. So I'm doing a problem on page 35. And it's a percent problem that sets up proportion, which basically leads us to an algebraic equation. And then I thought I'd do a little bit of discussion of algebraic equations, and that'll help us for the word problems in January, because word problems are, everyone knows, typically the hardest part of math. And you will see them as you continue to do the math lessons and testing and tests. Okay, so I'm going to show you the, moving to the whiteboard here, I'm going to show you the proportion that I like to set up is two fractions, right? Two ratios that are set equal to each other. And there's a couple different ways to think of percents and calculate them mathematically. I just think proportions are almost your easiest, and kids kind of like them and are comfortable with them. So I'm going to show you the equation they give you on page 35, and they don't give you the cute little kind of trick specifics about it. So I'm going to give you that. And I'm looking here, they also talk about percent on page 23. They have some percent, and I think they use the decimal multiplication, which is another way to do it, as I discussed, but proportions are really nice. You can say your percent, so let's see if I can draw percent. Your percent over 100. So whatever your percent number is, that number, like if it's 30%, we're talking 30%, they give you the percent, you put 30 over 100. So that's percent over 100 equals, and then basically it's your is, and I would use a calculator typing right now, but because it's a fraction bar, it just was going to get messy. So I'm writing it out, which, as you know, I don't love. Percent over 100 equals is over of. So if you say, you know, what percent is 60 of 70, and so your is value is your 60 and your of value is your 70, because what you basically are setting up is the ratio of 60 over 70, and that will calculate your percent. And using the percent over 100 is basically saving us from having to do the decimal. So what you can do is, what I like about this one is, if they give you the is number and the percent number, you can put those, place those right in the proportion, and then make your x the of number that you don't know, and then you solve the proportion. If you have the is and the of numbers, so then you'd get that fraction right there, you still are calculating a proportion because you're solving for your x, which is the percent. So if you have x over 100 equals, I'm going to stay small here, 3 over 5, then you could calculate that proportion. And what I like to say with students is butterfly it. So you make it into butterfly wings and you multiply. You do some cross multiplication. So 5 times x, so we always like the number in front, and 3 times 100 would be 300. Right? And then you divide here by 5. The opposite of the multiplication here, 5 times x, is division. So divide both sides by 5. And x is 60. So the answer to this one would be 60%, right? And I did want to show you the butterfly before we actually got to the problem. The problem for this one states that they ask what percent, oh, I should have given you a different version of one. They ask what percent of 72 is example, again, example on page 35. What percent of 72 is 9? So what percent, again, we don't know percent. So x over 100 equals 9 over 72. Now, why did I know that? Because they say of 72 is 9. So the of value was 72, and the is value that they listed in that problem was 9. So is over of is the value of a certain, normally a larger quantity. So obviously 72 is a little bit larger too. Okay, so if I cross multiply here, butterfly, 72 times x, and again, putting the number in front equals 900. And then dividing both sides by 72. 72 is taken care of on the left, and 900 divided by 72 is, I think officially we came out with 12.5, and I'm just going to use, you can have your calculators on your phones or what, I'm sure you can't use your phone on the test, but you'd have to do some basic division there, and I'm not going to spend time doing that, obviously. I noticed as I was going through the basic math lesson packet, they have some examples of some long division and division, how you solve a 72 into the 900, and they do a nice job of explaining it there. So that's something to look at if you would not know how to do this on your own and get 12.5. And not a nice clean percent, but 12.5 is a nice one to work with. There. Okay, this leads me into some algebra setup, and again, this will lead us into some word problem work. Just by looking at that one algebra problem, you know, we have basic multiplication and division. So if we have 4x equals 32, what we just did is we said, well, the opposite of multiplication is division, so we divided both sides by 4. And x, in this case, would be 8. We started with multiplication, and we used division to undo that work. If we start with division, x over 5 equals, let's do a nice small number. So we're just talking small numbers here. Obviously, you know the value here. 15 divided by 5 is 3. But let's talk about the steps that you would do if you had huge numbers here. And even in word problems you get, well, sometimes you do get large numbers, you know, 352 tickets for a concert are sold, blah, 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 number of students on a bus, blah, blah, blah. So sometimes you get, those examples wouldn't have decimals because you wouldn't have like a 0.4 or anything, but they're still big numbers. So x divided by 5 equals 3. You could probably tell me right now that's 15. How would you solve something with bigger numbers? You do the opposite division, which is to multiply both sides by 5. And when we multiply both sides by 5, the division and the multiplication by 5 undo each other, and x equals 3 times 5, which is 15. Okay. If I was doing adding and subtracting, I'm going to go real quick here because this is probably self-explanatory. If I had x plus 4 and I had a 12 here, obviously you know this is 8. Why is it 8? Because you would do the opposite operation, which is to subtract 4, right? And subtracting 4, you get x equals 8. Okay. One more algebra problem. And that would be something a little bit more messy. We'd have two things to work with here. Let's have, you know what, maybe I'll just change colors. Won't get too confusing. If I have 2x minus 5 equals 17. The steps here are actually the opposite of order of operations, and they require you to take care of any adding and subtracting first. When I say order of operations, remember I'm talking about PEMDAS. And it's funny, when you start to solve equations, you're going to work backwards and take care of any adding and subtracting first. and then any multiplication and division. When you're simplifying with something that doesn't have an equal sign, it's just a normal problem, not a normal problem, a basic problem that has no equal sign where they ask you to simplify it, meaning making it small, get down to one value, one answer, as small as you can, as clean as you can. Then you're going to go in the order of PEMDAS, which is to take care of parentheses, exponents, multiplication, division, add and subtraction, like we've done, we did in one of the first earlier lessons. When you're solving equations with an equal sign, so this equal sign gives me the right now to start doing opposite operations to get x by itself, to isolate x and solve for it, then I'm actually going to work backwards and take care of any adding and subtracting first, and then multiplication, division. I'd hate for PEMDAS to confuse you, so this is for algebraic equations only when you're adding and subtracting. So we're going to add 5 to both sides, because we're going to take care of any adding and subtracting first. So if I move the 5, then I can isolate the 2x, and then I can get, in essence, move the 2 and isolate the x, which I want. 17 equals 22, plus 5 equals 22, and you've got the 2x on this side. This is now gone. That was a 0. We canceled that out. This is, again, multiplication, so division by 2, and x equals 11. The nice thing, I'm getting messier and sloppier as I move too fast. The nice thing about this one, again, you could probably kind of think through it. Oh, what number minus 5 equals 17? Okay, 22. I need this to be 22, so x must be 11. That is great common sense and intuition, and if it works for you, awesome. The minute you get some fractions in there, some positive and negatives, some decimals, again, setting up a word problem, it might get a little bit more complicated. So I'm going to kind of use that overview of algebraic equations, and I want to do one more setup, which I think will be a nice setup and lead us into the word problems in January. And that is to show you a system, which means 2 algebraic equations that are basically placed together, and they both have 2 unknowns. They both have an x unknown and a y unknown. And I know that's a little bit different than what we just did, but it's all kind of wrapped in the algebra concept. I'm kind of taking the basic math and just running with some algebra ideas. And that is like if you have 3x plus 2y, and I'm just going to do one example today, and then we'll do more in January with an actual word problem setup. 3x plus 2y equals 14. And let's do (1x minus 2y equals a negative 2). And that negative's kind of funky in there. It obviously might not necessarily be a word problem, but you could have, you know, be out $2 in a bank account or something like that in your wallet. So a negative 2 shows up here in this problem. The thing about this is there's 2 unknowns, and what process we're going to use is what's called elimination. So I'm throwing a lot of stuff at you today, but kind of all based around, like I said, these basic math concepts, and then some algebra equations and proportion work that you end up having to do. You add straight down, and the nice thing about this is the setup for this example is obviously nice and clean, and the y's are going to end up canceling out when you add straight down. But other problems, you might have to do a little bit more work to get the elimination set up. So if I add 3x plus, this is an imaginary 1x, I get 4x. Adding straight down 2y and a negative 2y cancel each other out. And then this equals, what's a 14 and a negative 2? Basically, you're subtracting the values, you get a 12. So again, we end up with an algebra equation like we were just discussing, 4x. Just like our proportion work, we ended up with something very similar. So I was kind of hoping this would all kind of come together to help us for a couple different types of situations that you may see in your lessons or on tests. So 4 times, so the opposite is divide both sides by 4. And x equals 3. Now, you're actually not done here. The x value is 3, but what you also need to find out is the y. Now, what you did in combining these two problems and eliminate the y, this x equals 3 should give you an option for either the y value in the top equation or the bottom equation. Hold on one second here. All right, I just realized I could pause it, and I had a quick little interruption, and it's funny, didn't get to start on time today and an interruption. Okay, x equals 3. You should be able to plug it into either equation. You're using two equations and you were able to eliminate the y, but x equals 3 should give you the same y value in either equation. So I normally say to students, do the cleaner one. You've got the -2 here in the bottom one. However, the top one has bigger numbers. I think I'll go with, you know what, since we haven't discussed positive and negatives officially, I think I'll go with the top one, but you would see that you should get the same value on the bottom. So 3 times 3, because it's 3x, 3 times 3, so I'm plugging in x here, plus 2y equals 14. Okay, and 3 times 3 is 9, plus 2y equals 14. And then you'll notice here, this cleaned up with the 4x equals 12 into a nice simple division problem. However, in this problem, we have a couple more steps like we just talked about on the earlier whiteboard. So I need to solve for y here. I need to get y by itself. I need to move the 9 first. I need to subtract it. It's basically being added in this on the left side. And so to undo that operation, to move the 9, the plus 9 value, the positive 9 value on the left, I'm going to move it over and join the 14 here, and then I can isolate the 2y, and as always, we want to isolate the variable. So the 9's cancel out, and 2y equals 5, and this is going to be a clean answer, which I kind of like. Divide both sides by 2, and y is 5 over 2, or you could say 2.5. We talked about undoing improper fractions in one lesson, one mini instruction. You could change it into a decimal, 2.5. That might be easier to understand depending on if you are in a word problem situation. Obviously, you can't have 2. I always say to kids, you can't have 2.5 people on a bus or something like that. So make sure it makes sense if you do get a decimal in your word problem. So the list goes like this. You can give the x comma y in parentheses. So you could have a 3 comma 2.5. And they just don't like to do points there. All right, a mix of things today. Proportion work, system equations, and some algebra equations, all added up to algebra equations. All right, I'm in the chat room if you have any questions. Thanks. Bye.